It is given that the frequency of a stretched uniform wire of certain length is in resonance with the fundamental frequency of closed tube. If the length of wire is decreased by 0.5 meter, it is in resonance with the first overtone of closed pipe. The initial length of wire is. So according to the first statement, we can say that the frequency of a stretched uniform wire of length L is in resonance with the fundamental frequency of closed tube. So if you are just considering a string of length L and which is oscillating in its fundamental mode of oscillation, this is in resonance with the fundamental frequency of closed tube. So we know that in case of closed tube, let's say if it is oscillating in its fundamental mode, then the situation will be something like this. So we know the equation for their frequency for string. We know that the equation is V divided by 2L, and for the closed pipe which is closed at one end, we can write the frequency is nothing but V divided by 4L. Let's say length of this one is L2, so we can take it as it is 4L2, and length of this one is taken as L1, which we can take it as V by 2 L1. And it is given that their velocities are their frequencies are equal. The length of wire is decreased by 0.5. And in the second portion, it is given that if the length is decreased by 0.5, now we can just consider the length of string is equal to L1 minus 0.5. Then it is going to oscillate with the frequency, take it as N2, which is equal to V divided by 2 into L1 minus 0.5. And it is in resonance with the first overtone of closed pipe. So if you are observing the first overtone, then it is going to oscillate something like this. And if it is oscillating in the first overtone, we know that its frequency, let's say it is represented by N2, which is equal to V divided by 3V divided by 4 into L2. So our aim is to find out what about the value of its initial length. Now according to the first case, we can write N is equal to V divided by 2 L1. Let's say velocity is V1, which is equal to let's say velocity of sound is V2 divided by 4 L2, equation number 1. And in second case, the frequency N2, which is taken as V1 divided by 2 times of L1 minus 0.5 is equal to V2 divided by, or 3V2 divided by 4 L2. Now if you are going for equation number 1 by equation number 2, so we'll get it as nothing but L1 minus 0.5 divided by L1 is equal to 1 divided by 3. So we can write 3L1 minus 1.5 is equal to nothing but L1, or we can take it as 2L1 is equal to 1.5, or you can write the value of this L1 is equal to 1.5 divided by 2, which is equal to 0.75.